This conference will now be recorded.
Hello, this is the video for the Unit 3 review, the questions that you guys have sent me or that we didn't get to in class during the review session. So I'm going to be starting off with 2D, which has two vectors that were given to us, A and B. And it says to find the vector of magnitude 26 in the opposite direction of B. So we're focusing on vector B, and they're forcing a very specific magnitude of 26, which may or may not be related at all to the magnitude of the original B. So when they are forcing a magnitude of a specific value, you need a unit vector, because a unit vector has magnitude 1 and can easily be adjusted by stretching or compressing to any magnitude we want. And that would just be done by a scalar multiplication. So let's first of all find a unit vector of B. So to do that, you have to find the magnitude of B, which is the square root of -5 squared plus 12 squared, looking at our B vector up here, which is 25 plus 144 under the square root, which is square root of 169, which is a 13. Now, technically, that is related to 26 easily if we just double our original vector, but I want to show you that even if it's not related to that number that they want, we can still force it to have a magnitude of 26. So the first thing you do after you find the actual magnitude is you find the unit vector by taking each of these components and dividing it by that magnitude. So it would be -5 over 13i plus 12 over 13j. So that's the unit vector. Now, to get a magnitude of 26 and in the opposite direction of B, you would want to multiply by a negative to do the opposite direction and 26 to scale it. So then we would multiply this unit vector we just found by the following -26. So negative times negative is positive, and 26 and 13 reduce and give me a 2, so that would just be a positive 10i. And 26 and 13 reduce and give me a -2 times a 12, so that'd be -24j. Which notice I know that I could have fixed that just from looking at the magnitude of the original vector, which was 13, because 26 is just double that, and we went in the opposite direction. So essentially, it was just doubling this and changing the direction. But you won't be guaranteed that the magnitude of the original vector you were given is a multiple of the number they want. So this is the process if you can't easily adjust it. Okay, and then we want to look at number 3, part A, which says find the magnitude of C and the exact angle theta in 0 to 2 pi that corresponds to C. So for this one, we want to find the magnitude first, which means we want to do the square root of 7 squared plus -7 squared. That's the square root of 49 plus 49, which is the square root of 98. And that would be a 7 on the square root of 2 because it's 49 times 2. So my magnitude is 7 square root of 2. So that's the first part they wanted. This would be in quad 4 because it has a positive x but a negative y component, horizontal and vertical components. And this is the same length, so this is going to be a 45-degree angle, which in this quadrant, in terms of radians, that would be 7 pi over 4. And that's all you need to do for that one. Okay, for number 4, this is also just seeing if you understand how to convert. If you're given the magnitude and the angle that is between the two vectors that we're usually measuring, or any vector essentially, you can find its x and y components, or I and j as we like to call them when we're talking about vectors, by doing the magnitude times cosine theta for the x and the magnitude times sine theta for the y. So a vector a1, a2 is always the magnitude of a times the cosine of the theta and the magnitude of a times the sine of the theta. So that's my horizontal, like x, and my vertical. Okay, so we just need to work this out. Now, the magnitude is the velocity in this case, because remember, velocity is a type of magnitude in a vector. So we're just doing 18 times cosine of the 30 degrees, because that's how the angle is measured for the vector. And we're doing 18 times sine of 30 degrees. This would be 18 times square root of 3 over 2 using our unit circle. This is 18 times 1/2. So this is 9 square root of 3, and you want to keep your same units, so miles per hour. And this would just be 9 miles per hour. So this is the horizontal one, and this is the vertical one. So we're just asking you to find those components of the vector. So this would be the vector 9 square root of 3, comma 9. Now, of course, if we're going to place that vector somewhere, we would also want to ask questions like, what's the direction it's facing, all of those things. But they just wanted us to find the components. All right, so 7 is using those complex multiplication and division, essentially. So the nice thing about this one is it's already in r cis theta, so you don't have to do any work to find that. You just have to use the formula, and on the test, we do allow you to leave these in the formula, the cis theta formula. So the formula for how we do z1 times z2 is that you multiply the r's together, so that's 2 times 8 cis, and then we add the thetas. So 3 pi over 4 plus 4 pi over 3. That would be 16 cis, and then we need a common denominator here. So we'll multiply this guy by 3 over 3, so that'd be 9 pi over 12. Multiply this one by 4 over 4. That'd be 16 pi over 12. That is 25 pi over 12. Now, if this is bigger than 2 pi, we have to adjust it, and it actually is. So we have to take away 2 pi from this, which would be like subtracting 24 pi over 12. So it's actually going to reduce down to just pi over 12, because 25 minus 24 is 1 pi over 12. Now, if we're doing the division, same idea, except you do 2 divided by 8, and then you subtract the angles. I'm going to go ahead and write them as they already have the common denominator. That'll just save us a little bit of work there. So that's 1/4 cis, and then that would be negative 7 pi over 12. And again, that is not between 0 to 2 pi. So in this case, we want to add 2 pi to that. So that would be 24 pi over 12 minus 7. That's going to be 17 pi over 12. So 1/4 cis, 17 pi over 12. So you will lose a point if you don't get your final angle between 0 to 2 pi, because the directions clearly say that it must be between 0 to 2 pi. All right, let's look at number 8. I was requested to do both of these. This was the very last theorem we learned. It's de Maras Theorem. And essentially it says that if you know your magnitude and you know your theta for each of these, then you can easily find the final answer. And on these, we do want our answer to be in a regular complex number form. So the first thing you want to find is kind of the magnitude of that, guy. So that'd be 1 squared plus negative 1 squared. So that's going to be square root of 2 if we work it out. And then we want to graph what that is. That is a 1, negative 1. So that's going to be in quad 4. And sides are the same. So that's 7 pi over 4. It's a 45-degree angle. So this would be in the formula. You do the radius that you got, or your magnitude essentially, to the 4th power. And then you do cis, and then you do this power times the angle. So 7 pi over 4. So this would be, that's going to get squared twice essentially. So that'd be a 2 times a 2. So that's going to end up being a 4. You could work that on your calculator if you need to. Here the 4's are going to cancel and we get 7 pi. I would subtract 2 pi 3 times, because that would be we go backwards on the circle 3 times. Excuse me. Because that would tell me that this lines up with pi. Now, I need that to be able to get this into a plus bi format. So I do 4. Remember, this expands to cosine plus I sine. So 4 times cosine pi plus 4 times sine pi with an I. Cosine of pi is negative 1, so that's going to be negative 4 overall. Sine of pi is 0, so that's just going to be plus 0i, which we can reduce to just negative 4. Technically, if the algebra person in me, the algebra teacher was in me, I would actually leave it as negative 4 plus 0i, because that is technically a plus bi form. But on the answer key, he's reduced it to just negative 4, so I'm okay with that as well. So let's talk about this one next. So the Magnitudes would be negative square root of 3 squared plus 1 squared. So that's going to be 3 plus 1, so that's square root of 4, which is 2. The location of this is in quad 2 because it's a negative square root of 3 and a 1 for the components. And this is a 2. So remember, this is actually a 30, 60, 90 triangle. And because remember, this is your radius of 2. So across from the square root of 3 is 60. So across from 1 has to be 30 degrees. And that would be 5 pi over 6 for that one. Okay, so then we would then take this and plug it into the formula. So 2 to the third cis, and then it is 3 times the angle. And that would be 8 cis, and then this reduces and gives me 5 pi over 2, which again is outside of the 0 to 2 pi. So I'm going to subtract 4 pi over 2 because that's also 2 pi. So this is 8 cis pi over 2. So that's 8 cosine of pi over 2 plus 8 sine of pi over 2i. And cosine of pi over 2 is 0, so that's going to be 8 times 0. Sine of pi over 2 is 1, so we get just 0 plus 8i, or as the answer key has it, as just 8i. Okay, so that's it for the non-calculator portion for questions that I was emailed. So let's look at the calculator portion, and I had 10b circled from when we were in class. This is solving a triangle. So let's look at it. This one is, let's see, we are given A, B, and alpha. So let's draw a picture of what we think that would look like. It's always the best place to start. So big A, big B, big C. Alpha is 12.3 degrees. Little a would be across from that. Little b is across from big B. And because this is side-side angle, in other words, anytime you're doing a law of sine situation, which we are because we have an angle across from this side, and we're missing an angle across from this side, you have to be really careful here because if you have a single angle, it's always possible that you could get 2 triangles. So we just need to be careful when we set up our problems. So if I use law of sines here, this would be sine of 12.3 degrees over 45.6 equals sine of beta, which is what we're looking for, over 78.9. So let's work that out on my calculator. So 12.3 sine times 78.9 cross multiplied, and then divided by the 45.6. I know I'm not going to write all the answer out, but I'm going to write a little bit of this. So 0.36. I'm not going to clear my calculator. 859 if we rounded there, equals, so this is approximately sine of beta. The reason I did this is so you could check to make sure this is not bigger than 1. If it's bigger than 1, then the triangle does not exist. If it's less than 1, then it is definitely possible you could get 2 triangles, and you should consider that case. If it's ever equal to exactly 1, that means you have a right triangle. So just remember those were some cases we talked about in 8.1. So I'm going to do sine inverse of this, which gives me 21.63 to 2 decimal places. So beta, and I'm going to call this beta 1, could approximately be 21.63. And that is definitely a possibility because that's bigger than 12.3, and this side that's across from it is bigger than 45.6. The beta 2 option, which I'm going to draw another triangle for, is 180 minus that. So I'm just going to subtract 180 from this. So 158.37. Okay, so that's my 2 possibilities for beta. So I'm going to redraw this picture over here with an obtuse beta. So A is still 12.3. This is 158.37, 45.6, 78.9, and this one has my 21.63. Okay, so for both cases, we should be able to find gamma immediately by subtracting from 180 the 2 angles that we have. So let's do the first triangle. So 180 minus 12.3 minus 21.63 is 146.07. And for the other triangle, we have 180 minus 12.3 minus 158.37, which leaves us with 9.33 as the angle. Okay, so the only thing we're missing is little c on both of these. So this one is 146.07. This one was 9.33. So we're doing law of sines for these. So this would be, and always use your original setup, which is the 12.3 and the 45.6. Just helps you make sure you didn't round something too much. And that would be sine of 146.07 across from little c. Same thing over here, we would have sine of 12.3 over 45.6 equals sine of 9.33 over c. This would be c2, this would be little c1. So let's solve both of these. So 146.07 sine times 45.6 divided by the 12.3 sine. So this is 119.48, and that's not an angle, remember that's a side. So 119.48. Yep. And then over here, let's do this one. So 9.33 sine times 45.6 divided by the 12.3 sine. That is 34.70. All right, so there are my two possibilities for my triangle. I'm going to double check to make sure they make sense real quick before I say that it is truly my final answer. And remember, there's a rule about that. Each side has to be across from the angle that has the same placement from least to greatest, essentially. So if your biggest angle is this 146, that should be across from your biggest side. Your smallest angle, which is 12.3, should be across from your smallest side. So that's true here. 9.33 is actually the smallest angle here, so 34.7 is smaller than 45.6, and the beta is across from the biggest side. So as long as that works, then you should have two working triangles. Okay, another question that you guys had was to just rework the 4 word problems, so I'm going to do that really quickly. So it says a hot air balloon is flying between 2 towns that are 32 miles apart. We'll call those towns A and B, just to make it easy. The first town's residents can see a hot air balloon in the air somewhere at an angle of 18 degrees. So it's actually going to be closer to them since the other angle is smaller. And the other group can see it at 14 degrees from the horizontal. So 18 degrees, 14 degrees. What is the altitude of the balloon? So we're looking for the height rounded to the nearest tenth of a mile. Okay, so the first thing I would do is focus on the big triangle, which is this is 18 and 14. So we should be able to find the angle inside there. So that would be 18 plus 14, and we take that away from 180. So that angle is 148. And that's across from our 32. The reason I needed that was so I could find one of the other sides of the triangle using law of sines. I'm going to go for this one. That's what I did in class. So sine of 148 over 32 equals sine of 18 over x. So that would be 18 sine times 32 divided by the 148 sine. That comes out as 18.66. Okay. Now, I want to find the height of this hot air balloon, which is actually, that's a little right triangle inside there. So we can just use right triangle trig to finish this off. So this is H. We know this is 18.66, and we knew this was a 14-degree angle. We don't know how much the bottom is because this is not dead in the center of the 32 miles. We have no idea if it's 17 or 12 or where is it at. So I would use sine here because opposite and hypotenuse. So sine of 14 degrees is h over 18.66. So we'd multiply the 18.66 times the sine of the 14 degrees. And that gives me 4.5 miles if we round to the nearest tenth in the air. Okay. The next one's the cat in the tree. So a cat is stuck in a tree across the street from an apartment building. So let's draw a tree. And a cat is somewhere up in the tree. I don't know why my cat looks like that, but that's what it is. And then there's this apartment building across the street. And we're assuming that they lie on level ground. Yeah, the best we can draw it. So these are right angles then to the ground. So a resident whose window is 18 feet above the ground looks up. So if this is at 18 feet here, that resident is looking up at the cat, and there's going to be a horizontal that they're measuring from, and that has an angle at 21 degrees. Okay. There's another resident who is higher up, 87 feet off the ground, and they're looking down at the cat. So there's a horizontal for that person. And they're looking down. Again, try to draw the best you can at 51 degrees. So this is 87 feet above the air. This is 18. So we can find the length of connecting kind of the windows or the people by subtracting those. So 87 minus 18 would be 69. So that's this length right here. And that's the only thing we know about the actual triangle right now at the moment, because we don't have any other information inside the triangle. And these are angles that are outside the triangle. But we're assuming that this was all perpendicular to the ground. So these are then parallel to the ground. So that means this is a 90-degree angle right there. So this is 90 minus 51, which makes the angle inside this part 39. And 90 minus the 21 makes the other angle 69. If we add those together, we can get the angle across. So 39 plus 69, and then subtract from 180. That gives me an angle of 72 over here. And that will let me get some information about one of the sides, because now I have an angle across from a side. So I can do law of sines here. And we're worried about what is the height of the cat. So the cat is this whole height right here, but part of that is already this 18 feet. So we're looking for h plus the 18 feet. So we're solving for this little h here, which means we're actually solving a smaller triangle in this corner that goes from the cat to the red line over to this window and then back up. So we're going to need to know this side of this triangle to be able to figure out how to solve that little right triangle there. So I'm going to use law of sines and 72 and 69 and the angle 39 to solve this. So this will give me that x value. So sine of 39 degrees over x equals sine of 72 degrees, put my little degree symbols, over 69. We will cross multiply on that. So 39 sine times 69, the number, divided by 72 sine, is 45.66. So I'm going to redraw this triangle right down here. We're looking for h. This is 45.66, and we know that this is 21 degrees. So we can just use sine again because it's opposite over hypotenuse. So we're going to do 45.66. I'm actually just going to leave this as it is, times the sine of 21, which is 16.36. Okay, so we need to add that to the 18 feet. We already know the cat is in the air. So this is 24.4 if we round, oh, sorry, 34. I did not carry. This is 14, carry the 1. So 34.4. So this cat is 34.4 feet in the air. All right, so a farming supply salesperson manages a territory that is triangulated by Indianapolis, Chicago, and St. Louis. The distance between the different cities is given. So I'm going to write, here's Chicago, here's St. Louis, here's Indianapolis. That's not a line. We'll just move Indianapolis. You can just move a city, right? So from Indianapolis to St. Louis, okay, so let me go back. Indianapolis to Chicago is 180. From Indianapolis to St. Louis is 240. And St. Louis to Chicago is 297. And it says how much territory. That means area. So because this is three sides of a triangle, I'm going to use Heron's formula, which means I would need to figure out the perimeter and then cut it in half for the S, because remember the Heron's formula is square root of area equals the square root of S, and then S minus A, S minus B, S minus C. You're multiplying those four things together and then square rooting them, where S is always your perimeter of your triangle cut in half if you have your all three sides. You could also use law of cosines to find the largest angle, which would be I, and then you could use the side angle side formula we have, which is 1/2 the side times the sine of the angle in between. So there is another choice here. 297 plus 180 plus 240 is 717 divided by 2 is 358.5. Okay, so my area is going to be approximately, in a minute, 358.5. Then I can just pick one side at a time. So minus 180 would be 178.5. Doesn't matter what order you do them in. 385.5 minus the 240 would be 145.5. And I didn't do minus the 297 yet. So 358.5 minus the 297 is 61.5. Okay, I'm going to double check my 240 real quick. 358.5 minus 240. Yeah, I typed in 385, I think. That didn't look right. 118.5. Okay, so then we multiply all those together. Oops, too big. So times the 61.5 times the 178.5 times the 358.5. And then we want to take a square root, which you can always just raise it to the 0.5 power. That's the same thing. And we get 21,595 miles squared, because it is area. All right, last one. Two ranchers are pulling a horse out of a batch of quicksand. The first rancher pulls with a force of 195 pounds, and the second rancher pulls with a force of 215. There's a 15-degree angle between the ropes the ranchers are using to pull the horse from the quicksand. What is the combined force being used to pull the horse from the quicksand to the nearest whole pound of force? Okay, so it doesn't matter where you put the horse and the people, but let's just say this is the horse, and that we're going to keep our life simple and say one of them is pulling this way and one of them is pulling on the x-axis, because remember, vectors can be put any way we want as long as the angle between them stays the same and their magnitudes stay the same. So this is 15 degrees, and this one will be a little bit shorter. So this will be the 195, and this will be the 215. It doesn't matter, just pick one to be one. Okay, so then we need the vertical and horizontal components for both of these guys. So this one is going to be 195 cosine of 15 and 195 sine of 15. This is at 0 degrees, so this ends up being a x-intercept. You could do cosine of 0 and sine of 0, but cosine of 0 is 1, sine of 0 is 0. So this is this guy. So we need to find a decimal approximation for that other one. So that would be 15 degrees cosine times 195. So that's 188.36 to 2 decimal places, because I'll round to the nearest whole at the very end, not too soon. 195 times 15 as a sine. That's 50.47. Now, When you're doing combined forces, you need to find what's called the A plus B vector. This is the resultant vector, and its magnitude will be the resultant force. So if we have to find, first of all, what is A plus B, then we'll find the magnitude of it. So we add our components together. Now it's easy for the Y component because you're adding 0, so it's just going to be 50.47. But we need to add 215 plus 188.36. That's 403.36. We're going to do the magnitude of that, which means we're going to square them and add them together and then take a square root. And that will be our combined or resultant force. So square that plus 50.47 squared, hit enter, and then we want to raise that to the 1/2 or 0.5 power for the square root. That would be 407 pounds. That would be the resultant force. Okay, so that is the end of this video. I'm going to also make you guys a little formula sheet. It may not come until later tonight, but I'm going to go ahead and post this so that you can start reviewing. Have a good weekend.